on normal distribution. In statistics, the normal distribution is one of the most important concepts that is used to describe many natural phenomena, from the heights of people to the scores on an exam. Understanding the normal distribution is crucial to understanding statistical inference, which is used to draw conclusions about a population based on a sample. In this video, we will start by defining what normal distribution is and explore its properties. We will also look at some examples of normal distribution and see how it can be used to analyze data. Whether you are a student, researcher, or just someone interested in statistics, this video will provide you with a clear understanding of normal distribution, its definition, properties, and example. So what are you waiting for? Let's get started.
What is normal distribution? Normal distribution, it is symmetric around the mean value. The mean, median, and mode of the distribution are all equal. The area under the curve is equal to 1, meaning that the total probability of all possible outcomes is 1. The standard deviation determines the spread of the distribution, with a larger standard deviation resulting in a wider and faster curve.
Normal distribution is widely used in statistical inference, where it is used to estimate population parameters from sample data, test hypotheses, and construct confidence intervals. It also plays an important role in many areas of science, engineering, and finance.
In summary, the normal distribution is a widely used probability distribution that is characterized by a bell-shaped curve with a symmetric and defined mean and standard deviation.
Symmetry. The normal distribution of symmetric around its means, which means that the probability of a value being above the mean is the same as the probability of it being below the mean. This makes that the mean best measure of the central tendency.
Unimodality. The normal distribution is unimodal, which means that it has only one peak. This peak is located at the mean of the distribution.
Asymptotic. The tails of the normal distribution approach but never touch the x-axis. This means that the distribution never reaches zero, but the probability of getting very large or very small values become vanishingly small as we move further away from the mean. Low parameters. The normal distribution is completely determined by two parameters, the mean and the standard deviation. Once these parameters are known, we can easily calculate probabilities and other statistical measures.
Standardization. Values of normal distribution can be standardized by subtracting the mean and dividing by the standard deviation. This creates a new distribution with a mean of 0 and a standard deviation of 1, known as the standard normal distribution.
Another important property of normal distribution is the empirical rule, also known as the 68-95-99.7 rule. This rule states that for any normal distribution approximate, 68.3% of the data falls within one standard deviation of the mean, 95.4% falls within two standard deviations of the mean, 99.7% of the data falls within three standard deviations of the mean.
Now that you have learned about the properties of normal distribution, let us now move on examples and how to solve it. Let's have this example. A continuous random variable x is normally distributed with a mean of 62 and a standard deviation of 4. Illustrate a normal curve and find the probability of the following. Since the mean is 62, the center is 62. To get the values of the point on the x-axis from the left, you need to subtract the standard deviation to the mean. To get the values of the point on the x-axis from the right, you need to add the standard deviation to mean of the normal distribution, so we get this. After we draw the normal distribution, now Now, we need to find the following. A. The probability of x is greater than 58 and x is less than 66. To get the probability of this, we need to graph first for us to easily calculate their probability. Since in the empirical rule, the first inflection point is equal to 68.3 and the shaded part on the probability distribution is the first inflection point only. Then, the probability of the normal distribution is 68.3%. B. The probability of x is greater than 62. To get the probability of this, we need to graph first. Next is to analyze the graph since the shaded of the graph is from 62 and above. The shaded region is the half of the normal distribution. And since in the properties of normal distribution, the whole normal distribution is equal to 1 and it's symmetric, then if the shaded part is the half of the normal distribution, the probability is 50%. See, the probability of x is greater than 54 and x is less than 74. To get the probability of this, we need to graph first. Since it says that x is greater than 54 but less than 74, then the shaded part is from 54 to 74. After that, we need to analyze the graph again. First, let's get the shaded region in the first half of the distribution. The shaded part is the 2 inflection point. Since the 2 inflection point is equal to 95.4, we need to divide it into 2. So 95.4 divided by 2 is equal to 47.7. After that, we need to get the probability of the other half. Since the shaded part is the 3 inflection point, since the probability of 3 inflection point is equal to 99.7, and we need to get the half of this. So we get 49.85. After that, we need to get the sum of the probability we get from the two sides. So 47.7 plus 49.85 is equal to 97.55%. D. The probability of x is less than 58. First, we need to graph. So, from 58 and below are the shaded region. After that, we need to analyze the probability distribution again. Since the shaded region is from 58 and below, and you can observe in the graph that the first inflection point are the only area in the distribution that doesn't have shade. So, we need to divide the value of the first inflection point into 2 and subtract it to 50. Since that we only observe the half of the normal distribution, the half of the first inflection point is 34.15. Therefore, 50 minus 34.15 is equal to 15.85%. In conclusion, normal distribution is a fundamental concept in statistics that plays a crucial role in understanding and analyzing data. Its properties, including symmetry and the empirical rule, provide a quick and easy way to estimate the spread of a normal distribution and identify outliers. By understanding normal distribution, we can make more accurate predictions, estimate parameters, and test hypotheses about data. We hope that this video has helped you gain a clear understanding of what normal distribution is, its properties, and its examples. Remember that normal distribution is just one of the many tools available to statisticians and data scientists, and it is important to use it appropriately and in conjunction with other statistical methods to draw meaningful conclusions from data. Thank you for watching, and we hope to see you in future videos on statistics and data analysis. Bye!